All right. Hey, how's it going, guys? Mr. Fortin here. Keep an eye out for these on the jam boards. When I have the little finger pointing at you, that means I'm asking you, can you do this? Can you do this? Because if you can do this and explain it to the class, then you, my friend, have earned a homework late pass, right? Remember those times where you're just too tired to do geometry homework, you don't do it on time? That's fine. You have a late pass, use it. Go to sleep, do it the next day. It's fine. You'll still get full credit. Anyways, I have these late passes here. If we don't have time to explain it in class, because, again, we don't have much in class time this year, then you can just film a video similar to the video that I'm going to film right now. So I did have one person in class share a really cool way to solve a problem like this. The only issue I had with that one is that they use the fact that this is a triangle here, and that these three angles would have to add to 180. And remember, when we did this section, this one is from section 2-3, we hadn't actually proven yet that the three angles of a triangle add to 180. So if we haven't proven it yet, you can't use that as a rule because there's another way to do it, right? Another way to do it that's proven that we know is certainly true. So I'm going to take you through that, and I'm going to film this much faster than other video. The other video was really good, but I got a faster way here. Okay, our goal here is to prove that this line, and I'm going to extend it actually here, this line down here in red, are parallel to each other, right? Parallel to each other, okay? If these actually were parallel to each other, right? In section 2-3 is all about proving lines are parallel. What other things would we have to know are true? What other things do we have to know are true? Well, interestingly enough, we have two lines right here. We would know things about their transversals. So I'm going to highlight in this transversal, sometimes just tracing out the things. Transversals in purple, and the other line is in green. We'll put the other one in green here. We see things jump out to us. So I know that in tests and on things that I hand out in class, people generally do better on problems like these. But it makes it hard to do out of the textbook. So just copy this diagram down. If you really want to get it or figure out this puzzle, copy it down because then you can trace over it here. Okay. So I have two lines. They're cut by a transversal. What are some things we would know? Ooh, we have some angles here. An angle here, an angle here. And yeah, I guess those are the two angles of significance that got cut by this line here. And then this purple line right here makes this angle. This green line here and this purple line here, ooh, makes that angle. So these are, yes, these are corresponding angles. So if we knew that this line, this angle, were congruent to this angle, that would be enough to prove that these two lines would be parallel. So what I'm going to do is actually create an equation that if we knew that this were true, then we know that the two lines would have to be parallel, okay? The problem is here, we're trying to find the values of x and y that make the red line parallel. This thing here isn't solving for x, nor is it solving for y, so we got to do more work here, okay? So this is something that I think is going to be a systems problem. In chapter 4 of Algebra 1, for instance, that's when we go over systems, but perhaps you saw a bit of that last year. Maybe they didn't get to it because it was a little bit abbreviated, but you'll learn it this year in Algebra 1 if you are in Algebra 1 this year. But anyways, there's one equation, okay? We got one equation involving x and y. Let's see if we can get another one, okay? So I have a transversal here. Look at this. I actually already have another transversal. So remember, if you have any line segments that are running between these two potentially parallel lines, that would classify as part of a transversal. And then this is a little bit more, in descriptive of what the transversal is. Because remember, transversal is a line, so touching two other lines in two different points. And that would fit the definition of transversal. So now we have, it looks like we have an angle formed by this green line, and the red transversal right here. So we get this 5y right here. And we have another line, angle here, with this green line, right, which is one of the two lines we're trying to get parallel, and the transversal. So we have this angle right here and this angle right here. So this angle right here and this angle right here. And what's their relationship here? Remember, this is the transversal right here. Transversal right here. These are on alternate sides of the transversal, and they're on the interior of the two green lines. These are alternate interior angles. So if we knew that these alternate interior angles were congruent to one another, then that would also make the two lines parallel to one another. So let's do that now. Let's set up another equation here, okay? So if I knew that 5y equaled 2x, then I would know the two lines were parallel, okay? So what remains here is I need to find the values of x and y that are going to make both of these equations true. And you could guess and check, you could do that kind of thing, but the better thing is to solve the system, Okay, solve the system. So what this system is a system is a system of equations, which is two or more equations involving the same variables. This is a first equation, equation A. This is equation B right here. They involve the same variables, and we can work with both kind of simultaneously to solve this problem. So one thing that we could do, for instance, is we could do substitution. So that's the way that I'm maybe going to solve this one. There are some easier ways to solve it. I'm not going to get into that right now. I'm going to do where my brain went first, and that is I'm going to isolate x on this equation, okay? And so that means I need to divide both sides by 2. So right now I'm going to isolate x to substitute, okay? To substitute. That's the way that I'm going to do it. It might be an easier way to do that, but I'm going to ignore that. I'm just going to substitute x to isolate here. So 2 divided by 2 is 1. And here I'm isolating x. X is going to be equal 5 over 2. We can't simplify that, so I'm just going to leave that. I'll maybe switch 5 over 2. 5 divided by 2 will be 2.5, and we'll make that 2.5y. Okay? So x equals 2.5y. And here in the first equation, okay, substitute into the other equation. Okay, so I'm going to use the substitution method of solving a system here. I have x in this equation. I know that x is equal to 2.5y. And what the substitution property of equality means, if we know one variable or one thing is equal to another thing, then we can substitute that other thing for that thing into another equation here. Okay, so what I get is another equation here, equation C, let's make it, would be 30 is equal to not x anymore because x is equal to 2.5y. I'm going to put 2.5y right there. And I'm going to have my subtract y right there. Okay. So now I have only one variable in this equation. That's very, very nice. So now I can solve for y. 2.5y minus 1y would be 2.5 minus 1 is 1.5. I get 1.5 right there. And 1.5 is the same thing as 3 over 2, so I can multiply by the reciprocal, which would be 2 over 3, or I can just divide both sides by 1.5, use a calculator, and 30 divided by 1.5 would actually be 20. I'm not going to use my calculator right now, but feel free to use your calculators, right? Use what's easiest for you, and a lot of times that's calculators here. Okay, so I got 20 for y, and now I'm going to substitute into this equation right here. Remember, we had an equation that said 30 equals x minus y. If I plug in 20 for y, then 30 equals x minus 20. So I'm going to add 20 to both sides, and I'm going to get 50 equal to x here. And those are my answers. 50 minus 20 equals 30. Checks out in that equation here. I'm just going to quickly check my answers in my head. 2 times x is 2 times 50, and that's 100. And that's equal to 5 times 20, which is also 100. So it works out here, okay? Maybe a little bit of time since you guys have solved the system, so hopefully that was a bit of a review with you. If not, if you're in Algebra 1 right now, you're going to study systems later on in the year and solving them here. You don't need to worry about something like this for a test or a quiz in this course, because I know some of you guys are taking Algebra 1 this year, okay? Email me if you have any questions. Right now that we've proven that this is a, 50, so we can also visually make sure it makes sense too. This is a 50 minus 20, so this is a 30-degree angle, and that makes sense, right, based on the context of the problem. Yeah, 30, 30. Look at it, there we go. 50 minus 20 is 30. We're good to go. And then this one here would be 5y, so this would be a 100-degree angle. It looks like a 100-degree angle. And this one's 2x, 2 times 50 is 100. It looks like a 100-degree angle, and we're good to go, okay? I'm interested if you can solve for the triangles, because this would be 110 plus 30, that's 140. So is this 40 degrees? Okay, and this is 40, and then, oh, this is vertical to that one here. So this one should be 30. So I don't know if there's a flaw in this problem. Anyway, yeah, this would be 40 here. Okay, let's see, 100. Oh, I'm just kind of like daydreaming right now. This would be 60. Okay, what's missing here? In the 360, 140. 200, 240, 270, and then 90. Yeah, you might have a flawed problem here. Anyways, I was just kind of thinking out loud. Anyways, yeah, there's your answer. So I'm going to wrap up this video here. I'll talk to you guys later. Bye. Let's see. And I got it done. It was longer than the other video. Bummer. All right, see ya.